So our first section is going to be about simple and compound interest. And I would think that if you've gotten this far in your educational career, at some point you've actually done problems with simple interest and probably even with compound interest. But we're going to add a little bit more into it at this point. The thing that I want you to pay attention to in this chapter, the math isn't going to be hard because even if the formulas look a little complicated, we have a built-in finance calculator on your TI-83. So as long as you know what the different terms are, as long as you can pick out the different variables, you'll be able to load the numbers into the calculator and it will actually give you the answers that you need for the questions. So the hard thing for you, or it's not necessarily hard, but the different thing for you is this is going to be more like a science class or a foreign language class. You're going to have to learn terminology. You're going to have to learn what all these new words mean. So the first thing we're going to talk about is simple interest. And the formula for simple interest is actually pretty straightforward. The interest amount is the principal, which is also called in most finance formulas the present value. What do you put in today? Which is why it's called the present value. R stands for the rate, so it's the interest rate, and T stands for time. And P has to be given in dollars, R is the interest rate expressed as a decimal, and T is the time, and it has to be the time measured in years. So if, for example, you're trying to find the interest for 6 months, you're going to have to say 6 over 12 gives you 0.5 and use that for your time. So the first problem we've got, our example says to buy furniture for a new apartment, Pamela Shipley borrowed $5,000 at 8% simple interest for 11 months. How much interest will she pay? Now, she's not going to wait till the end of the year and pay it off. She's going to pay it in 11 months. So the way that you do this problem is 8% is the yearly interest rate. In the simple interest formula, it has to be the yearly interest rate because the time is in years. We need to know the time of the loan in years. So we're going to convert 11 months into years by dividing 11 by 12 and then use the formula with P is equal to 5,000, R is equal to 0.08, and T is equal to 11 over 12, and there's no reason to convert that to a decimal. You can put that in as a fraction. Just put 11 divided by 12 inside parentheses. So it turns out that the interest rate in this particular case, or the amount of interest that she's going to pay, is $366.67. So what that means is if what she bought was, let's say, a $5,000 car at a simple interest rate of 8% and paid for it in 11 months, making monthly payments on it, then she will have actually paid $5,366.67 for the car, which is a really good deal, but it's also a really short interest period. Credit unions actually do still use simple interest rates. Banks do not. Bank uses something called an amortization interest rate that we'll get into later. But you actually can still get simple interest rates at a lot of different credit unions. Our second example is about maturity values. Maturity means at the end of the loan. The final amount in the loan is oftentimes called the future value. So future value and maturity value mean the same thing. And by saying future value, then you know that means something that happens later, not that happens now. So let's say that you deposit P dollars today at a rate of interest R for T years and produce interest of I equals PRT. The interest added to the original principal gives you, as I said in the last problem, it was just the amount of a loan in that case, but this time it's an investment. You take the original amount that you invested plus the amount of interest you get, and if you factor out the P's, the P comes out in front and it's P times 1 plus RT. This is still a simple interest rate formula, but it works then if you have multiple years. So the future value is given by A. P is again the principal, the present value. 1 plus RT actually accounts for both the principal and the interest being added at the end of the time to give you the value of A. So here's an example with some numbers in it. Find the maturity value or the future value for each loan at simple interest. We have a loan of $2,500 to be repaid in 8 months with an interest rate of 4.3%. The way that we find the answer to that is we plug into the formula. A is our future value. It's what we're looking for. The principal, the amount we invested, is $2,500. And then the loan is for 8 months. So for 8 months, 8 over 12 is 2/3 of a year. You could actually just use 8 over 12. You don't have to change that to 2/3. And that would be then 1 plus 0.043. That's the interest rate of 4.3% times either 2/3 or 8 over 12. And when you do the math, it turns out that the future value, or the amount that you pay at the end of that loan, is $2,571.67. So you basically paid $71.67. That was your cost of borrowing the money. That's what you could think of that as. In financial problems, we always round to the nearest cent, and we use the regular rounding rules. If you want to know the amount of interest, then of course you can just take your future value minus your present value, which is what I just did, and that's where the 71.67 comes from. Questions so far? Okay, our second example, Part B. What if you had a loan of $11,280 for 85 days? And the interest rate is 7%. And again, that's an annual interest rate, but it's only for 85 days. It's common to assume 360 days in a year when you're using a formula for simple interest, even though there's 365 days in a year. Commonly, just to simplify the math, they use 360 days in a year. So 85 out of 360 days is going to be the fraction for the part of the year that you had the loan. The interest rate is 0.07. Your present value is $11,280. So you borrowed $11,280, and at the end of 85 days, you actually paid an interest amount that is the difference between the $11,466.43 and the $11,280 you actually borrowed. Of course, 85 days is not a very long time. That's less than 3 months. And the comment here is meant to draw your attention to the fact that any time that we're going to do anything in this chapter that regards a year in as being numbered in days, we're always going to call it 360. So what they always have done in finance is they assume that you have 30-day months, even though some are 31, and one of them is 28 or 29. It works out well to just assume that all are 30-day months. This is one for you to work. Find the maturity value or the future value for a $3,000 loan at 5.8% interest for 100 days. information. Have had enough time to at least set it up, so I'm going to go through this stack of test papers and call on people. Sarah. What is the principal or the present value?
Sorry, Taylor.
It's okay.
About 20,400.
No, the present value. I'm not asking you for the answer, I'm just asking you to identify the variables.
Oh.
Okay, so
Which
what's the
one?
present value?
P is at 3,000.
P is 3,000. Okay. Weston,
Yes.
what is R?
R is .058.
Okay. And Josh Neal, what is T?
100 over 360.
Okay. So if we do the math, what will we do first? Seth, what will we do first? What would you do first?
Multiply inside of parentheses.
Okay, multiply inside the parentheses. So we probably want to do this part first.
Where'd you get the 360 from?
360 days per year. Even though there's 365 days in a year, finance always assumes that there's 12 30-day months, which is 360, okay? So that part of the formula is .016111111, and I need to add 1 to it. So the part that's inside the parentheses is 1.016, 1 repeating, and the way that you can indicate that the 1 continues to repeat is just draw a little line over it. And I need to multiply that times 3,000. And then that'll give me the future value. So the future value of the loan is $3,048.33. Now on the calculator, it would have been perfectly okay if you had entered the problem this way. I have three sets of parentheses open, I need to close 3 sets of parentheses. So there's 1 closed, 2 closed, so I need 1 more. And you can go straight to the answer, but it does require that you enter sufficient parentheses to do it that way. And you cannot skip the parentheses around the 100 over 360. You absolutely cannot skip those. Okay? The next problem is a little bit more challenging, so I'm going to work through it with you. But I'll still probably call on you for some answers. So find the interest rate if $5,000 is borrowed and $5,243.75 is paid back at the end of 9 months. What was the interest rate? Now, if you're smart, you knew what that was before you signed on for that loan. But we could find the interest rate if we needed to by plugging into the formula and doing a little bit of algebra. So again, your formula is A is equal to P times 1 plus RT. We know P we also know A, the future value. And we know that they're going to pay it back in 9 months. So T is going to be 9 divided by 12 months. And again, what we don't know is the interest rate. So that becomes our unknown in the equation. So we're going to practice your algebra skills a little bit and then maybe look at some technology ways that you can do this. So we're looking for that R. So a little review for solving equations. I need to divide both sides of this by the 5,000 because it's 5,000 times everything in the parentheses. And what I'm trying to find is in the parentheses. Now, I'm not going to do any of the arithmetic until the end. I'm just going to carry everything along. At this point, I've got a fraction and my expression in R on the other side, and this is 1 added to R times something, so I need to subtract 1 from both sides. So now I've almost got it solved for R. Not quite. I need to actually multiply by the reciprocal of 9 over 12 on both sides. So 9 over 12 times 12 over 9 cancels everything out and becomes 1. And my interest rate then is equal to 12 over 9 times the quantity $5,243.75 over $5,000. Subtract 1. I have to do everything inside the parentheses first. So again, step by step. There's that fraction. From that I subtract 1. And then I multiply that answer, because this is everything that's inside these parentheses. I multiply that answer by 12 over 9. So my interest rate is 6.5%. Okay? Anybody have any questions? If I were to ask you to do this on a quiz, could you do this? Okay. Go back to the PowerPoint for a minute. So we solved that one. And we've now solved this one. Now we're going to talk about compound interest. Everything we've done up to this point is simple interest. You need the handout that's in D2L.
Okay.
Or, yeah, I emailed it to you in D2L. Carl, you'll need to go in D2L and print the handout.
All right.
It's attached to an email. Okay, the compound interest amount is kind of like the simple interest amount. Because you notice up there, it's the future value is equal to the present value times the quantity 1 plus I, not R times T, but then what is I? It's the rate times the time. Okay, that's the interest. And on the outside, you see something called N. And that's because the interest in this case is going to be compounded not necessarily at the end of a year. It could be compounded at the end of a month. It could be compounded at the end of every 6 months. It could be compounded at the end of every 3 months. And this is the way actual loans do work. Most loans are not done with simple interest. Most of them are done with compound interest. So we need to, again, this is the language. A is the future value. P is the principal or present value. R is the annual interest rate. The annual interest rate. N is the number of times you're going to compound every year. So if you compound once a year, N would be 1. If you compound every 6 months, N would be 2. If you compound every 3 months, N would be 4. If you compound at the end of every month, N would be 12. T is the number of years. N is the number of compounding periods. And I is the interest rate per period. Interest, or the I value, is always the rate divided by the number of compoundings. And N is always the number of compounding times the number of years. So that's one version of that formula. I'm going to go over here to the notes for a second, and I'm going to give you a slightly modified version of that before we go on. one that it might be easier for you to remember how to do everything all at once. A is the future value. P is the present value times 1 plus, it tells you right here that I is R over M. So go ahead and put that in the formula. That might be an easier way to remember it. And N is M times T, and since the power is M, the power is M times T. That way, if you use this formula instead of that formula, you don't need to think about what this is. So when I give you the formula sheet for the test, I'll probably put the formula on there that way, because it's easier for you to remember. Now what you're going to have to remember, though, is what all these things stand for. You're going to have to memorize what all those variables stand for. If I were you, I'd get some index cards, put the variable on the front, and then write what it is on the back. And just when you think about it, flip through them. There's also electronic versions of flashcards. You can get an app that makes flashcards. But I think it actually helps you remember if you actually take the cards and write them out. So your turn 3. Find the amount of interest earned by a deposit of $1,600 for 7 years at 4.2% compounded monthly. So we've got our formula up here. And it says the amount of interest earned. So this is the formula for the future value. Now, if we want to know the amount of interest earned, what we're going to have to do is find the future value first. So, the future value is the present value times the quantity 1 plus R over M raised to the power MT. Tara, what's the present value?
1,600.
Okay. Noah, what is the value of I?
The rate over the number of compound periods.
Okay, so what would that be?
1.0042.
0.042.
Okay.
You move your decimal 2 places. So it's 0.042. And what are the number of compoundings a year? 7 years, but how many times do they?
Monthly.
Okay, compounded monthly.
12.
So it's going to be 12. Thank you. Caleb, what's the value of T in this case?
7.
Okay. And if it's compounded 7 years monthly, then what's the value of MT going to be?
84.
Say again?
84.
Okay, good job. There's no need to actually write that part of the formula out unless you want to. So now we need to actually calculate the future value. So we're going to do that. We're going to have a calculator. And again, we're going to do what's in parentheses, in the innermost parentheses first. So to avoid all that garbage, I'm going to clean that off. 0.042 divided by 12. So that's the per period interest rate. Plus 1. Raised to the power of 84. And then times 1,600. So the future value is $2,145 and 75 cents. But what they actually asked us was find a month of interest earned, the total interest earned. So we need to subtract our 1,600 and find the amount of interest earned. And the amount of interest that was earned was $545.75. So you always want to answer the question. Now, it's in your notes, you don't have to do it right now, but I would suggest that you look at the technology note on page 203 of your textbook, because that's going to tell you how to do the calculator. Yes?
Where'd you get the 84 at?
The 84 is 7 times 12. Sorry.
Since it's compounded monthly, you have to do times 12?
Yes.
Okay.
So T is equal to 7, M is equal to 12, so M times T is 12 times 7, which is 84. Okay?
It's a compounded yearly, you wouldn't have to do that, right?
Yeah, if it was compounded yearly, you wouldn't have to do that, but they're compounding every month. Now, the question is, why would you want them to do that? Because this is like a savings account or a certificate of deposit. Why would you want them to compound at the end of every month rather than just at the end of the year? Is there an advantage to that?
You might have a really good purchase that takes a bunch of money out of it, then you would be...
Because they pay interest more times?
They pay interest more times, so when you get your interest on the first month, that's just added to your principal, right? But then your principal becomes higher. It's the principal plus that first month's interest. And then the next month, they're going to calculate your interest on a higher amount than the original principal. And then the next month, they're going to calculate your interest based on your original amount plus 2 months' worth of interest. And then that's going to continue. So what happens is the amount that the interest is being calculated on throughout the year grows so that your interest grows faster. And at the end of the year, you'll have more money. If you only did this exact same problem and it was only compounded yearly, I'm going to show you what the difference in the answer would be. If you took 1,600 times 1 plus, the interest rate is 4.2%, so that's 0.042. Which if you look, you know, you say, well, hey, that's a lot bigger interest rate than 0.042 over 12, and yes, it is. But here's what makes the difference. This time you're only going to raise your power to 7 because they're only going to calculate interest once a year. So 7 times rather than 84 times. And you get $2,133.99. Now, is that a huge difference? You get $533.99 as opposed to $545. Simply by not compounding monthly. Now, is that a huge deal? No. But if it's on, let's say, $160,000, yeah, that's a huge deal. That's a lot of money. Or if it's on a better interest rate than .042, that's a lot of money. So the reason that you would want them to compound monthly, if it's you that's getting the money back at the end, is because it means you get more interest. Okay? Now, this is the exact same process they use when you make a big purchase, like a car or a house. This same formula is the formula to find the maturity value or the future value of your mortgage payment, which is something I'm going to ask y'all to do at some point in this class. I'm going to ask you to go comb through and find a reasonable price for the house that you would really love to own someday. And then check out the bank rates. You can find those all kinds of different ways, but check out a bank that you can tell me is going to give you that mortgage rate. And we're going to have you calculate what the future value of your house is going to be for a given mortgage. That's going to be your project for this. Okay? So this formula, this one formula right here, is a very, very important formula to everybody in the country, because this is the formula they use to calculate car payments, house payments, investment payments, all kinds of things. So this is really relevant to you. So here's our our calculations that we just did. And the technology note actually is going to show you how to do this calculation on the calculator, and I'm going to show you the same thing right now. Your finance formulas, if you look at your little x to the -1 key that we use to find the inverse of matrices, if you look right above it, it says finance. And the one that we're going to use is going to be the TDM solver. And N in this case stands for the number of compoundings. I is the interest rate that's stated in the problem. PV is present value. You enter your present value as a negative if you're trying to solve certain kind of problems. Like, for example, the future value. Your payment might be something you want to solve for. If you don't want to solve for it, leave it at 0. FV is, of course, your future value. P divided by Y is the number of times per year that it's compounded. So this looks like this particular example, they were compounding quarterly. And P divided by Y and C divided by Y should be the same thing. They should always be the same value. So for you to see how they got the information on here, and then we'll actually do a problem, is if we put in 26,
What did you press to get that again?
second, and x to the -1. Now the TI-84, this screen may look a little different because y'all's actually prints things out a little bit clearer.
What do you, if you have a TI-84, what do you, because it doesn't come up if you push that.
Go to apps.
Yeah, go to your apps on your 84, and I don't have one handy. Let me finish this one in, then we'll go through it with the 84, okay? Because I can get the 84 example up for you to show you where I got it. So the interest rate here was 5.25%. Notice that it didn't ask you to put it in as a decimal, it asked for a percent. The present value of the loan, again, if you're trying to find future value, you put your present value in as a negative. So their present value was $24.50. We're not asking about the payment, so we just leave that at 0. Because it calculates for the one thing you leave blank. So I'm going to blank that one out. Sorry. No, you have to leave it as a 0. And then put in 4 for the last two. And we'll talk more later on about when is it the end and when is it the beginning. But basically, this is compounding at the end of each period. So if we just hit enter, it doesn't do anything, but if you hit second enter, I'm sorry, not second. If you hit alpha enter, it's supposed to go to solve. My calculator's stuck. You go to the textbook. Okay, if you go into My Stat Lab and Tools for Success, we don't want the manual, we want the tutorial. And we'll go, this is for the TI-84, for those of you that have the 84. And this will also help us with the 83, it's just we access it differently. And that was not, okay, it's applications, the TVM solver. So N is the number of payments per compounding period. I is the annual interest rate, PV is the present value, PMT is the periodic payment amount, FV is the future value, and if 4 of these are known, the solver will find the 5th one. P over Y is payments per year, C over Y is compounding periods per year. So we're going to step through this problem. I'm going to scroll down so we can see the steps. And you can work with me on your calculator. So on the TI-84, you press apps. And then since finance is chosen, you choose enter. And then you choose TVM solver by hitting enter. And we'll do the problem that they're asking us to do. So in this problem, we have a house for sale for $175,000. That sound like a house you might want to buy? That's not a bad price. You could probably buy a house on an acre of land, and the house probably would have maybe 2-3 bedrooms, as long as you didn't get too carried away and want something that was huge. So you could probably spend that much on a house. What would your monthly payments be if you financed it for 30 years, which is what most mortgages are financed for, is 30 years, at 7.5% interest? Now, current interest rates are not that high, but we're going to do this for 7.5% interest. So, at N, that's the number of payment periods for the life of the loan. So if you're financing a loan for 30 years, you're going to make 12 payments a year for 30 years. So N is going to be 360. I'm trying to figure out why it wants me to press the buttons I'm pressing. So I'll go ahead and press them. Okay, it's going to make me actually multiply it out. That's okay. So N is 360. The interest rate says it's 7%, 7.5%, so we press 7.5.
So you wouldn't put .07?
No, because it said, if you look at what it asks you for, it says N%. So it's going to convert for you. And then your present value of the house, that's the $175,000. zero. And your house payment's what you want to know. You want to know what your payments are going to be. So you leave that with a 0. And the future value, we don't know what that is either, so we leave that as a 0. Your number of compoundings per year and your number of payments per year, that's going to be 12. And silver-wise is going to be the same. And if you put your cursor on what it is you want to know, it'll give you that value. That was what I was getting to do on the 83 a minute ago. And if I actually wanted to know what the future value was, well, I can't do it here, but I could actually down arrow to my future value amount and hit alpha enter, and it would tell me what I actually am going to pay for that $175,000 house at the end of 30 years, what I will have paid in total. And it will be a little surprising. So that's how it works on the TI-84.
How did you get the answer?
Excuse me?
How did you get the answer for the payment?
You put your cursor on the payment, which was 0. It started out being 0, and then you hit alpha and enter.
You got negative? Did you use negative?
It won't let me move the cursor, but yes, I think it's negative.
Okay.
So let's go through the same problem on the TI-83 so you can see how it works on the TI-83. Once you get to it, it's exactly the same. So on the 83, we go second, x to the negative 1, choose the solver, and our problem, I'm not going to do the multiplication, I'm just going to go ahead and enter in the 360. And 7.5% interest. And the present value was $175,000. I don't know the payment amount, I don't know the future value. There are 12 compoundings per year, and there are 12 payments per year, basically. So you move your cursor to what you want to know. I want to know what my payment's going to be. And then I'm going to hit not the second, this is different, not the second key, the alpha key, and enter. So there's your payment amount. You pay $1,223.63 every month for that house. Okay? And you do that for 30 years. At the end,
That's hard.
it's not going to do the future value. So I'll go back up and put 0 for the payment. At the end, you will have paid $1,648,768.43 for that house.
How'd you get it to pop up again? Oh, 0.
You have to put the 0 in and then second, or not second, put the 0 in and then alpha, enter. Because if you look at your enter button, it says solve above it. It's with the alpha key, not the second key. Okay? Does that surprise you? Surprises most of us. But that's a pretty hefty interest rate. It is really a hefty interest rate. So be aware, once again, this was in my stat lab, in my math lab, and it's on Tools for Success, and it's down here on the Graphing Calculator tutorial, not the manual, the tutorial. It'll show you how to use the TBM solver to forget between now and next class period. And then going back to your notes, this is simple interest versus compound interest, and we were actually talking about that a little bit earlier. If you look at a graph of the same present value is $1,000, interest rate is 1%, I'm sorry, 10% interest rate. Then if you have simple interest at the end of 15 years, your $1,000 has turned into $2,500. You say, hey, that's pretty good. Well, yeah, that was the end of 15 years, okay? But if you had been getting your interest compounded, let's say yearly, not even monthly, but compounded yearly, not just simple interest, you would have had $4,177.25. I'm sorry, yes, 25 cents. So look at the difference in the amount of money that you would have by compound interest. Now imagine how much more that would be if instead of compounding once a year, they compounded quarterly or monthly even. You could actually make a lot of money. Or on the other side, since the bank basically when they loan you money to buy a house, that's their savings account and you're paying the interest, you could also pay a lot more. And again, this is if you go to a credit union to get a loan. That's if you go to a bank. So you might want to see if you can get loans at credit unions. See if and ask them if they do simple interest. So here's an example of compound interest rate if you need to find it. Find the annual interest rate of $6,500 is worth $8,665.69 after being invested for 8 years in an account that compounded interest monthly. So here's our formula. Interest rate is the principal value or the present value is $6,500 times 1 plus the annual rate is what we want to find. And it's compounded monthly, so that's 12 times a year. And 12 times a year for 8 years. And we know what the future value is. The future value is, and I'll add it on to the end of this, 86.65.69. So I need to solve that for R. So my first step is going to be to divide both sides by the 6,500. And that inside the parentheses is raised to the 96th power. Now the arithmetic at this point is going to get a little dicey, so I'm going to go back, since I'm going to run out of room, I'll go back to the PowerPoint. And if you take both sides to the 1/96th power, I'm going to show you on the calculator how to do that. You take your 8665.69 divided by the 6,500. And raise that to the power of 1/96. Now, basically, that's the same thing as saying I'm going to take the square root of both sides of the equation, except this time I'm taking the 96th root, because the power is 96. So here's what I'm doing, so you'll understand what's going on here. I'm going to take the 96th root of that side, which is going to give me 1 plus r over 12 by itself. And if I take the 96th root of that, that's the same thing as taking this quantity to the 1/96 power. That's what's going on here. And that gives me 1.003 and a whole bunch more numbers. And I need then to subtract 1 from both sides. And there's the interest rate. That's the interest rate over 12. So I need to multiply both sides by 12 now. And you find that the interest rate in final is, because what this is that's the monthly interest rate. The yearly interest rate is 3.6%. Okay? Now, we could do that one on the solver also, but given that we've only got about 3 minutes left in class, and I wanted to leave time for anybody that needed to ask any questions or do anything else, I'll come back and pick up there and we'll work on it on the solver to show you that it's really not necessary to do all this arithmetic. And for the rest of the chapter, we'll mostly use the solver. Somebody need to ask about one of the problems. If anybody had problems on the last one on the test, you stick around, I'll give you hints.
If we leave our test back and work on it, or is it?
I will let you get your test back and see if you can finish it, but I'm only going to give you hints. I'm not going to work it for you, because it is still your test.